Hi everyone. In this video, we're going to be talking about like terms and collecting like terms. So in algebra, expressions are broken up into what we call terms. And terms are either a constant, which is just a number, or the products or quotients of a constant in one or more variables. Basically, it's the things that are separated by addition and subtraction. Now, the coefficient of a term is the constant that's being multiplied with the variables. Constant is its own coefficient. So if you see a number just by itself, and you want to know what the coefficient is, it's its own coefficient. Basically, this is the number in front of a variable. Two terms that are either both constant or have the same variables, which you're taking into consideration the exponents as well, are considered to be what we call like terms. So for some examples, x, 3x, 10x, these would all be considered like terms because the variable is x and the power is the same on each of these variables. You could look at x squared and 115x squared, and those two are still like terms because they have the same variable and the same exponent. In fact, even 2, 9, 13, which are just constants, would be considered like terms. For some non-examples, if we look at x and say 5x squared, and these two are not like terms. They have the same variable x, but the exponent is not the same for both terms. And if we have something like 8y squared and 8z squared, then these are not like terms either. Although the exponents are the same, the variables are different. So this would be another non-example of a pair of like terms. All right, so one of the key things that we're going to be doing in simplifying expressions is combining or collecting like terms. This is more or less boiling down to adding or subtracting the term's coefficients. So how do we do that? Well, it's two pretty simple steps. The first step is to identify which of the terms are like terms. And then the second step is to combine the like terms according to whatever operation that you're doing. So we're going to go through some examples just to see what I mean by that. So first example, we have 2x squared plus 5x plus 9 plus 3x plus 7. And so remember that the first step here is to figure out which of the terms are like terms. And we're going to group them together. So the like terms in this expression are 5x and 3x, having the same variable and exponent, as well as 9 and 7, because they have the same variable, which is to say none, and exponent. And so by collecting like terms, we mean that we are adding the coefficients of of the like terms. So 5x plus 3x boils down to 5 plus 3, which, I'm doing my math correctly, and you hope I am, it's 8x. And secondly, we're collecting these constant terms, which are like terms. 9 plus 7 is 16. And there we've collected all of our like terms. And if we want to do another example, let's see. Let's look at 5y squared plus 2y plus 1 plus 9y squared plus 5y plus 3. Is that long enough? Nah. Minus 2y. All right, so now we're going to identify which are the like terms. Let me separate here so it's a little bit easier to tell which problem's which. And we want to look for all the like terms with a squared. So 5y squared, is there any like term? Yeah. 5y squared and 9y squared. And as far as I can tell, there aren't any other ones. Next, we look at 2y. And what are the like terms with 2y? Well, we have 5y over here, as well as this minus 2y. And finally, 1 and 3 being constants are also like terms. So in collecting our like terms for 5y squared and 9y squared, we're going to add those guys together. 5 plus 9 gives us 14. And then we have 2y plus 5y minus 2y. So we're going to do 2 plus 5 minus 2, which is 5. And finally, 1 plus 3 gives us 4. And there we have it. All the like terms are collected. So that's everything for this video.